Yes, welcome. Thank you for joining my talk, which is called Doubling Down on GraphQL using REST. Are there any REST users in here? Would you use REST APIs? Oh, there are a lot of you. Oh, that's exciting. Okay, so today I will show you how you might be able to get rid of all those REST APIs and use GraphQL instead. Multiple things, but most of all I'll be showing how you can map your existing REST APIs to GraphQL and how they sort of fit into the paradigm of GraphQL. And also some issues GraphQL might not be able to solve for you. You might have heard around newer frameworks or things like tRPC or some other RPC models. So I'll probably use some time to tell whenever you should use those and whenever GraphQL could be a good use case for you. So one of the things I also usually get, if people come to me and they ask, I want to go to GraphQL, they typically have some legacy code hanging around. I heard a phrase tomorrow morning in the keynote, someone saying hero code, which is actually a nice one because there's probably a reason you keep this code in. It's done a lot of work for you, maybe it led to a lot of revenue, and you don't want to touch it because it's just too fragile to touch. So often I see people coming in with legacy code, or maybe it's also just pasta spaghetti code. They get sort of tired of the code base, they don't want to touch it anymore, and everything is just intertangled with everything, which is something you usually don't really like to have in your company. And often in these cases, I get people asking me, I want to have a GraphQL API and want to have it as fast as I can. And you might remember how much time it took you to leverage REST APIs, to get everything in there that you needed, to put in all the hard work, all the business logic that maybe your manager wanted you to put in. So if you want a GraphQL API and you wanted to have it relatively fast, I mean relatively is, well, it could be minutes, could also be days or hours or how long you want it to be, but it should be way faster if you are mapping your existing REST services to GraphQL. But often your manager just says no. It's something I get as well. Front-end developers want to use GraphQL, but they might have a manager that says we can't really do this. And this is a scene from the movie Office Space. I highly recommend everyone to watch it, especially if you are going to an office regularly. So a little bit about myself. My name is Roy. You can find me on Twitter with the handle @GetHackTeam. I do all sorts of stuff. Most of my time I spent at StepZen, which is a GraphQL company. So we help companies building GraphQL. Maybe at the end I can tell you a bit more about it, but most of this presentation will be focused on using GraphQL based on your existing REST services. I also fiddle around with some side projects. The latest one is something that helps me a lot when I create content for one blogging platform and I want to bring it over to all the others. So it's, I always like to say when you work in DevRel, you don't really write production code anymore. So sometimes it's just cool to create a side project that's actually being used by people. So it's my fair excuse of writing some production code. I write programming books in my spare time, and I also have tons of stuff on YouTube that you can find. I'm using the handle @GetHackTeam everywhere, so you can just find me using that. And also, it's my third time being here at JNation. So the first time was 2019, and then I believe I did a virtual one, but I'm not really counting it in either 2020 or 2021. And then last year I was here as well, and I already spoke to some people that saw my talk last year, so thank you if you are in the audience here again and you saw my talk last year. So it's always cool to see a community growing. I mean, last year there were less people than now, and in 2019 there were also less people, so it's good to see the whole tech community here in Portugal, and especially around Coimbra and whatever Portuguese city you might be from here today, growing, so that's always good to see. So I hope you stick around for the after party as well to meet all the other people in this nice community. So let's get to know you a little bit better as well. What do you already know about GraphQL? And for this, I have two. You're either A, you know how GraphQL works, and maybe there isn't much to learn for you here today, or maybe you wonder how this works. Is anyone B? You're still wondering how GraphQL works? Okay, quite some people. So I want all of you to stand up, if you want. You can stay seated if you have bad knees or a bad back. I don't want to get any troubles with your physiotherapist. Okay, great, thank you. And then we have a second group of people. Maybe you've visited JNation before, and please keep standing. If you visited JNation before, that's great. If you missed it, I also want you to stand up. So I want to see some people standing up, get the blood flowing through your body, and help support this community. Because if you take out your phone, and we have this great thing called QR codes, there's tons of talks from these conferences online. So if you would scan this QR code, you can find all the previous talks from the previous 5 editions, because it's the 6th one already. And you can just subscribe to them, and you get all the talks from previous years for free. And even if you go home today, and in a month or 2 months, maybe you try to remember this talk or one of the other great talks that you saw today, you can go to the YouTube and just find them there. So it's a great way to keep learning, and even if you miss the conference, quite often they still share the content with you online. So it's a great way to stay connected with things you might have missed, and also a good way to help the organization a bit, help them grow by subscribing to all their other social media things. Because I always like to say YouTube is a free university. I mean, I went to actual university, but I did economics and I hated it. But I might as well could have bought like a business book or a management book. And I guess for programming, YouTube is really the free university to teach you all the skills that you might haven't learned in university, or maybe the things you aren't learning at your current employee. So it's good to stay updated through all the stuff you find on YouTube as well. So back to today's topic, GraphQL. As I saw in the beginning, quite a few of you are still wondering how GraphQL actually works, which is great, because then there are tons of things for you to learn today. So for this, I'd like to start up with an example project, because maybe you get recruited by a new company, or some internal manager approaches you to work on a new project. And almost all the time they say it's the best project, it's the greatest project you can work on, you're going to learn a lot, maybe you should move to this project. And it's called the e-commerce platform of the future. I always hear people saying we've built the thing of the future, of whatever might be still in place in 10 years' time. So it sounds great. You hear your manager or recruiter saying, come work for me, come work for the e-commerce platform of the future. And you probably have heard this all before. And then you will look at their stack and you see something like this. You see a database, you see a REST API, you see JavaScript, and maybe a framework like React. So you probably start wondering, is this really the future? Am I still building with a REST API, or maybe a relational database, or maybe even JavaScript or React? Are these still the things of the future? I mean, as a developer, you don't really care if the e-commerce platform itself maybe has some unique edge case features that might be really good for the retail brands, but you care about the technology. And if you look at a technology like this, you probably start wondering, is this really an improvement? Because I've been building with React for 10 years, or I've been building REST APIs for maybe 20 years. So is this actually the platform of the future for me? So I'd say it's more an e-commerce platform, which is fine. I mean, tons of people work for an e-commerce platform. I worked in e-commerce for a long time, and it's really funny because you see problems you don't see in maybe other branches. If you build internal dashboards, you probably don't have to worry about performance, and in e-commerce you're worrying about performance every day. So let's go back to this situation. We have an e-commerce platform that we're going to build. We have a backend, which is a database and REST, and then we have a front end with JavaScript and some framework. In order to fill this UI, we're going to be using this REST API, and this REST API is connected to our database. So nothing fancy there. And the first thing you need to know about REST APIs, and you probably all know is you've been working with REST, is REST APIs have multiple endpoints. And this is something that always bugged me before, because it's really hard to explore where all these endpoints are, what they are specifically doing, and if I'm missing data, where should I actually get it from? Sometimes there's cool embeddings or links in it, but quite often there aren't. So they have multiple endpoints, meaning that if you'd like to fill this UI, you need to send requests to multiple endpoints. If you want to get the general product details, you probably have an endpoint for it. If you'd like to get the categories for maybe something like a breadcrumb, you also need the endpoint to get product categories. Same for reviews or ratings or whatever kind of things there are to load in this page. So it's multiple endpoints you need to call in order to fill your UI. And later on, I'll be showing some shortcuts you might have been using yourself, or maybe your backend team is using to sort of steer away from these multiple endpoints, which is all fine. But the biggest problem I see here is they return fixed data structures. And this might have been a real problem like 10 years ago. Maybe today it's less of a problem, unless you're working on this actual e-commerce platform of the future that is serving like millions of users every day. But they return fixed data structures. And this is because most REST APIs are directly tailored towards the entities you have in the database. So let's say you have a database table or a collection if you're using some sort of NoSQL database. And those would contain the data that you would also make available on one of these REST endpoints. So if you have a categories table, you typically have a categories endpoint. And if there's some relational table to connect the products and categories, you're probably going to serve those over a product/categories endpoint. So usually those things are mapped one-to-one to your database, which isn't necessarily bad, but it's one of the things I see happening with REST APIs all the time, even with GraphQL APIs, but that's a whole other talk. But quite often REST APIs are getting data from a single data entity, which is quite often a database. Meaning that for every request, you also get all the tables that are present in this database. Sometimes you try to hide some of them, which is a good thing. You don't need all those tables probably. But quite often, most of the tables in your database table, they will be returned for your REST API request. So if you're getting information about a product, you probably also get information that you don't really need. And the same for categories and ratings. You're going to get a lot of information that you don't typically need to use in your app. And when Facebook came up with the idea of GraphQL, it was actually needed because we had phones that might even be able to be foldable. I mean, we have foldable phones again, but back then we didn't have 2 screens on it. And they had way less bandwidth. Probably also your mobile bundle had way less bandwidth. So it actually mattered how much data you were sending back and forth between your application and the actual API. But today it still matters also, because even though your data bundle might not be the issue, you're still sending all this data back and forth, meaning that there is a data center somewhere, and also your device is working hard to get all this data in to make sure it renders on a screen. So all this data you don't really need, it actually consumes energy. So it's something I thought about recently. You're not only helping to keep your data plan smaller, you're also helping to keep the data centers from doing unnecessary calls back and forth. But it's like an additional thing. It wasn't the reason they created GraphQL. They just wanted data to be sent back and forth faster. So to fill this UI, we need to call 3 different endpoints that all return fixed data structures. So this is perfectly fine if your endpoints are tailored towards the specific UI you're using. But quite often you want to use those endpoints for other things. Maybe you even have an endpoint for your mobile app that's different from the endpoint for your web app, that's different from the endpoint for your admin app. And they're all using the same database tables, although they have slight differences between the data they return. Which is all good, but it leads to a lot of additional overhead. If you have one backend team, it might be fine, but you see companies where they might have 4 or 5 or 6 backend teams all working on the same API. And if you create this whole mess of different endpoints for different needs, it gets kind of, it might even get kind of smelly in your whole code base because you're duplicating a lot of things, you have to maintain more code, and it's one of the things I don't really like, so it's one of the reasons for me to start looking into things like GraphQL. So GraphQL, in return, it has a single endpoint which returns flexible data structures, meaning that you no longer have this whole mess of multiple endpoints that return a lot of data. Instead, you have one single endpoint, and you, as the end user, as a developer, or maybe someone you built your public API for, they're able to select which fields are returned by the API. And this is a great thing, as this gives you control over the data that you get in your application, as opposed to REST, where you don't really know what kind of data you're getting. Quite often for me, the first interaction I have with a REST API is making a call to it, either from my browser or from something like Postman, and just look at all the tables. Because there is documentation, but quite often it's outdated. Sometimes it's auto-generated based on the code, but more often I see it's really outdated and it's manual work for the developers. So GraphQL is a single endpoint with flexible data structures. So what does this mean? It means a lot of things, but let me begin with explaining what GraphQL actually is. Because often I get people asking me if GraphQL is a framework, or it's a library, or it's a technology, or it's a service. But in fact, GraphQL is best described as a query language for APIs. It's actually nothing more than a spec. So it's a specification describing how creators of API libraries need to implement GraphQL for developers like yourself. And we also have a foundation now, so it's no longer just a spec. It's a specification together with a foundation, meaning that there is a group of people actively maintaining this specification and helping all these libraries to create the best possible GraphQL API experience. It looks a bit like this. So if you've never seen a GraphQL API, quite often you interact with it through a playground or some sort of API discovery tool. You can even use things like Postman with GraphQL nowadays. And at the core of every GraphQL API will be a schema. And in the schema, you can find a set of types. And for this set of types, you can find fields, and you can also find operations, such as queries, if you want to read only data, or mutation if you want to mutate it, or subscription for real-time data. Are people in here using TypeScript? Oh, that's great. I really like TypeScript, and if you know TypeScript's type system, you're going to see a lot of similarities between the two. There are some small differences, but most of the syntax here is pretty much the same, so it shouldn't be too much of a learning curve to learn how these annotations in the schema look like and how you would create a GraphQL schema. But as mentioned, you can find all the types here, all the fields, and also the operations that you can use with GraphQL. So this is the schema. It has all the type definitions. There are sort of built-in types. You can call those everyday types, like you know from TypeScript. These are the ID, string. There are a few others, like Boolean and float. Unlike TypeScript, there are multiple ways to define a number. So whereas TypeScript just has number, in GraphQL you float an integer. So you can imagine these serve slightly different needs. For an e-commerce app, for example, price would always be a float because you might have decimals, whereas the IDs often are integers or counts are integers. So everything is defined in a schema. And to access this data, you need to find an overview of all the queries or operations. So there are multiple operation types. And an operation you would send to a GraphQL API will look a bit like this. You would need to define the operation type. In this case, it's query. So I'm retrieving data from the API. I define all the fields, and I also define the name of the operation, which is product. And I can even add some arguments there. And then the response will look something like this. It's always JSON, so it's great to know if you work with REST, you get JSON. If you work with GraphQL, you would also get JSON data in return. And you can find all the fields that you defined in your query. And this is something I really like when working with frontends. You send a request to the API, you define all the fields you like to get, and then your response will have these same fields in it. So you don't really have to guess anymore how my response will be structured. Instead, you just look at your request, and you'll be able to figure out what your response will look like too. And so with GraphQL, the thing is you ask what you need, and you get exactly that. I sometimes put a meme in here for the Spice Girls, but it didn't really do it today. But there's this Spice Girls song, which you tell me what you want, what you really, really want. And this is more or less what GraphQL does. You tell GraphQL what you really want, and it will give you the exact same data as you requested. It also offers a single endpoint for multiple resources. So it's the thing I don't like about REST. I need to send all these different requests, all these different endpoints. Somewhere in my application, I need to tie all this data together. I might need to do some normalizations. I might need to store them in separate state. I maybe even have separate states for every endpoint, and I want to bring them together at some other point. These are things you don't really, it's not the best developer experience. In GraphQL, you would get it all in one single request. So this is an example of what a Twitter GraphQL API would look like. So you all know the Twitter API recently got updated. You need to pay a lot of money for it. And the number of requests actually matters. So imagine sending all those different requests, all those endpoints. It's gonna cost you more money. If Twitter would have a GraphQL API, it would look something like this. In one request, you would be able to get a list of tweets and also the author for every tweet. So what the Twitter REST API does, it's a typical example of a REST API. If you search for a list of tweets containing a keyword, they will give you a list of tweets, but they don't tell you who wrote this tweet. They will give you an ID, but you still need to find a way to turn this ID into a person that tweeted the tweet you found with the first REST API endpoint. So in GraphQL, you would be able to get all this information in one request without having to optimize any of those things yourself. So relations are defined like this. You would often just have a field, and this field would have subfields, and this would represent the relationship with some other data things there. And of course, it doesn't come naturally. You need to create this as the creator of the backend API, but I guess that's sort of obvious. And most of all, as some of you are working with TypeScript, it's based on the type system. And for me, the type system is really the thing that sets it aside from REST API endpoints. It's not the only reason you should be using GraphQL. As I touched base in the beginning, if you only want a type system for your endpoints, there's things like tRPC, which might be a good fit. If you're looking for all these additional things, like a query language, having single endpoints for multiple resources, together with the type system, it's really where GraphQL adds the additional power you might need as a developer. So this type system, you can find it in the schema definition. It's the schema I showed earlier. But when working with a GraphQL API discovery tool or GraphQL API dev tools, you'll be able to find a visual representation of all these types too. Meaning that if you want to know the type of something, you could just go to this visual representation, which is also your sort of documentation page. Doesn't mean you don't have to write any documentation for GraphQL, but it's a good start to have this overview, this visual representation, and this overview of all your different types and possible operations. So like I mentioned in the beginning, it really improves the developer experience. Working with REST APIs, for me, it never has been a good experience. I was always fighting with the structure of my responses, which API endpoints are available. I was always looking for more data or expecting less data. With GraphQL, you get control over this, especially if you work with front-end apps or mobile apps. It's a better way to interact with your data, and it's way more developer-friendly. And it also introduces the type system that I mentioned, which for me is a huge upside. And you can also use this as a sort of data layer. So you might have heard about backend for frontends. GraphQL is a good backend for frontend. It's not really a replacement for a backend for frontend, and things like tRPC can be a backend for frontend. What GraphQL does, it offers a backend for frontend for all your apps, whereas most backend for frontends are tailored towards a single app. So maybe your current application will look like this. You don't only have a database or the REST API, but you also have all these external services. You might have a CMS, you have a CRM, you have an authentication service, you would have a payment service, and more you don't even develop these services yourself. So if I look at a basic app that I've been working on, like in most of my startups, before I went into DevRel, I was combining all these different services from different providers, and I didn't really have control over the sort of data they gave me, and I was also relying on them to keep giving me the same data, to not update their endpoints, and maybe also to give me data in some sort of normalized way that is kind of coherent with all the other services. So GraphQL can help you to combine all these different things, and it's something I really like of GraphQL. It doesn't really care where your data is coming from. If you would create a schema representation of your data, you will be able to bring this all together into one GraphQL API. So bringing together all this data from different services, it's a huge advantage. So the sort of mappings I'll be showing you in a bit, they can be a first start towards creating one of those schemas and then bringing those schemas together gradually. This also means that you can scale to an unlimited amount of clients and backends, so you can have one GraphQL API that's being used by all your different apps, because they're in control of the data. If your mobile app wants to have less data than your web app will have, or maybe your admin dashboard wants to use the same backend, but they get different data based on their authorization level. This is all possible with GraphQL, so it really brings you this data layer approach that can scale unlimitedly. So I'd say with GraphQL, you can turn this octopus into sort of one backend API data layer that not only brings together all your different data sources, will also help you with API composition and data normalization. So I'd say it's an added benefit when you would go on the GraphQL route, because GraphQL can do more than just create data for your database. It can create data for all your different backend data sources. And then another thing I like to tell you is GraphQL is often seen as a replacement for REST. If you would go to Google and you would type GraphQL versus REST, you can probably find hundreds of articles and videos and links to whatever kind of documentation from different tools and open source projects that tell you how to migrate from REST to GraphQL. But maybe you want those things to live side by side, which I guess is pretty fair, especially if you're building public APIs. Maybe you don't want to give away all this control to external clients, but you want internal clients to have all this flexibility. Or maybe you're working with service integrators that are expecting REST APIs, so you don't want to have only a GraphQL API, you want to have a REST API too. So it's often seen as a replacement, but they can actually easily coexist. I see a lot of companies using GraphQL for internal-facing projects, whereas they have REST for external things. If you look up the GitHub Developer API, they've done a great job in giving you both a REST API and also a GraphQL API. So you don't have to, you don't have to settle for GraphQL or REST. You can have both. It's this meme I created once. It's you can easily be married to REST and then still have some GraphQL on the side. This is not relationship advice, by the way, but they can easily coexist. And as a developer, you might really want to use GraphQL, but you're still tied to REST. And those are the sort of patterns that I will show you in a bit. So sounds great. Where do you start? So I already showed you some overviews of mapping REST APIs to databases. In mapping GraphQL to REST APIs, you can imagine there's a similar diagram. We have a database. It has all these data entities, and they're exposed through REST API endpoints. So if you start building a GraphQL API, the best part, sort of the greenfield part, would be to take your database and create GraphQL APIs for all your tables, make it available in the GraphQL API, and just move away from REST. But I guess in a more realistic setup, you already have this REST API, you've invested lots of time and money in it, your company is devoted to keep using this REST API, it can do more things than just get data out of your database and render it. So quite often you go to the situation where you want to map your REST API endpoints to GraphQL instead of mapping your database to GraphQL directly. And of course, whenever the GraphQL API has proven its value, you'll be able to sort of connect the GraphQL API to the database directly. But you probably don't need it in the beginning. And the way you would map these REST API endpoints to GraphQL would be through resolvers. And I'll tell you a bit more about how to create GraphQL servers and sort of how they are built up. But resolvers are sort of your functions to get data from somewhere and map it to your GraphQL schema. So if you would have a schema that would define your product type, the resolver would be responsible for returning the data of product type. And when you build your GraphQL API, you're the one that decides where it gets the data from. Is it from a REST API? Is it from a database? Is it from maybe even a JSON variable? So if we look at these mappings, we could start at the endpoints. You maybe create a resolver for getting data from your product's endpoint and getting data from your product/ID endpoint. So if you start working on a GraphQL API based on your existing REST, a good starting point would be to take some of the more generic endpoints and transform them into GraphQL. And if you would map them something like this. You would have your endpoints in REST, and then you would create your query type. So the query type is where you would define all the possible queries in your GraphQL schema. And this query type, you also have a mutation type if you want to mutate data, or subscriptions if you have real-time data. So they would define the name of the query. Quite often it's good to keep it sort of similar to your REST API endpoints. I always like to have lowercase things in GraphQL APIs and not make them too descriptive. Sometimes I see people using get products. It's perfectly fine to call your GraphQL query get products, but maybe you want to do something else. Maybe you only want to get a product ID. In REST APIs world, you probably need to create a separate endpoint that says get products_IDs or whatever if you only want to have something that returns IDs. So let's say keep them as generic as possible. And this also works for relational objects. Whereas with REST API endpoints, you typically say, I have an endpoint called /products. I have an endpoint called /products, and then I append some ID in the path name. You probably also want to append relationships with other data entities this way. So maybe have products / my ID / a different data entity. And this is sort of the way to map your data to other data entities in REST API endpoints. Whereas in GraphQL, it will look something like this. If you will look at your actual query, at your set of operations, you don't really know what kind of relations it has. You can only see it return something of type product. It can be a list of products, which is for the products query. It can also be a single product. And by looking at the product type, which you can see at the top, you can see all the fields for it. So you can see 2 fields that return only a string. And then you can see a 3rd field that also returns a different type. And in this case, it returns a list of review, meaning that there is a relationship with review. But the initial request to the products sort of query to get product information, you don't really care about all the relationships that there are downstream. Instead, you only care about getting data from product. And if you decide to include the reviews field in your request, you would get reviews in your response as well. If you don't include it, you won't even see this data, so you don't even care that it exists. Of course, you always have access to the schema for most APIs, so you would be able to find out the relationship exists. But as the user of this API, you don't really have to care until you need this data. Something I often get when people are mapping GraphQL to REST is sort of HTTP methods. How does this work? Because you maybe have heard that everything in GraphQL is a POST request, which kind of makes sense, right? Because you need to send your request. It needs to contain the operation you'd like to have. So you need to include your query or your mutation or your subscription. And that's why you always need to use a POST request. Because otherwise, if you do a GET, you won't be able to include this actual query or other operation type. So for read-only in GraphQL, in REST, you would have a GET request. So a GET request is always to retrieve data. You don't use it to mutate data. Maybe if you have a webhook, you might be able to use, well, you might use it to update some count somewhere, but let's say it's not really advised. And for mutating data in HTTP, you have many different ways. You have a post if you like to create new data. The second post should have been put, because you maybe want to edit data. Patch is also for editing data, and then you have delete. So you have sort of 4 ways to change data in REST API, sort of in a CRUD setup. Whereas with GraphQL, you would only have a mutation for all these different things. So this always annoyed me about REST APIs, because we developers, there's like multiple things that are hard in a developer's life, and one of those is naming things. So are you going to be using a put or a patch to let someone update a data entity in your database? I've had some nice debates with developers in previous teams around when we should use put and when we should use patch, and every single developer has a different opinion on which of the 2 we should use. So in GraphQL, they took a different approach, and they got kind of smart about it, and they thought, let's give you just one operation type to update all your data, no matter if it's inserting new data, editing existing data, or sort of deleting data that you have. So in a GraphQL schema, it might look something like this, where I said that I don't really like for the queries to have a very descriptive name. For mutations, I like it to be more descriptive. So I'd say if you have a mutation to create a product, the mutation itself should make it very clear that you're mutating a product. If you have a mutation just called product, it would be really hard for you to know what's going on. You can do it, as you see on the last row. You could maybe add an argument that says action. Action could be post or put or patch. It could be insert or delete or edit. It's another approach to do. For me personally, I like the mutations to be descriptive, but there are different routes you can take there. So in theory, you would be able to replace your entire CRUD operation to insert, delete, or update data with one single GraphQL mutation. And then there's also subscriptions. It's something I didn't really mention so far, as they don't really exist in REST API endpoints, because subscriptions are for real-time data. So you would need a WebSocket connection, you need to have a streaming API, or whatever kind of API you have that's able to produce real-time data. In GraphQL, this would mean you would need to create a second endpoint, because of course you need to have some sort of WebSocket connection to allow this, this data going back and forth in a sort of real time, in a streaming way. Something else that's interesting in GraphQL are HTTP status codes. And this again is something developers like myself and people I worked with like to debate. What kind of status code do you need to use for what specific action? Are you being very strict about it? Are you going to implement maybe 10 or 20 different status codes? Are you going to stick to only a few? So for REST APIs, you maybe have a 200, a 201. So I'd say, for me, actually, when I build REST APIs in the past, I typically say if things are going well, I always return a 200. Whereas some developers I worked with said, if you create a 200 for new data, you actually want to use a 201. And all these kind of debates, to me, it always felt pretty useless, but it's also the fun thing of being a developer, being able to debate every part of your professional life with other people. So if all these different status codes, quite often I don't really know what they mean. I found this list of adding an emoji to every different status code, so maybe it will help you a bit. I might have asked ChatGPT to do this for me, so if something is incorrect, don't really blame me for it. So in GraphQL, we only use 200. And there's a specific reason, because the GraphQL API will always try to return data. Whereas a REST API typically just says, I have no data to return, here's a status code, go figure it out yourself. Whereas GraphQL says, we're going to return you a 200, and then in our response, we're going to define whatever went wrong, and we're going to give you some hints to where you have to look for any possible clues to figure out what went wrong. And we do this by giving you an error code. So most of these are like 200 responses, everything is all right. If we look to the one on the left, which has a 404 not found, a REST API endpoint would probably won't even give you a JSON response. They will just give you a status code telling something went wrong. Sometimes they will give you a small error message, but quite too often I've seen REST APIs not being very descriptive in whatever went wrong. For GraphQL, you would get multiple things. You would always get your data back. So you can see we are requesting data, which is a product. But instead of returning no product, you would get null, meaning that in your application, you would still be able to process this. There would be a second field, which is called errors, and this would contain more data about what actually went wrong. Often it also includes trace data, so you can figure out whatever went wrong downstream in your API. And all these other sort of descriptions should be there as well. What I also really like about GraphQL, you can also get incremental data. So maybe part of your request failed, but the other part succeeded. So let's say you want to get our initial application, which we saw, you tried to get the title and the thumbnail and also the reviews. Maybe your reviews failed, maybe there was an issue with the data retrieval there, or maybe the third-party API you're using to get reviews from, I don't know, what are people using, something like Trustpilot failed. In GraphQL, you could decide to return a subset of the data instead. Query parameters are also fun in REST endpoints. There are multiple ways to do it. Sometimes you'll see the parameter itself being very descriptive. So it could be called Q, as in your search term. It could also be something like sort. Sometimes I also see filter or fields, which isn't really descriptive because it's sort of global, and you need to figure out what to do with the data yourself. So for this filtering, sorting, and whatever you like to do there in GraphQL, there would be one setup. One small slide in between. I often see REST APIs being designed to return a subset of fields. It's something that's OK to do. I mean, if you designed your entire backend API framework to work this way, it could be pretty fine. I would say it's more a REST-ish approach. I mean, if you go REST, try to go for something that's actual REST instead of finding shortcuts for the, well, sort of things REST can solve for you natively. Something else I like in REST APIs are links. I don't really like it, but I find them interesting. You can see people including links to different collections. So let's say you're retrieving a user by its ID. You can typically find a field called links or underscore links, and it would contain links to other places this entity exists in. So maybe you have a collection for users, which you can find on this REST API endpoint. All your REST API endpoints would be aware of all these relationships with other endpoints. And the same for posts, because maybe you'll be able to get posts from this specific user, and you would be able to retrieve them on a separate endpoint. Sometimes you also see embedded data, which might have been even a dirtier way to sort of make sure that your REST APIs don't necessarily return whatever they need to return, but instead to get other data entities in there as well. So typically you would add a parameter that says embedded is true, or embeddable is true, or maybe you even define the fields that you like to embed. I'd say these are all sort of REST-ish approaches, because pure REST should be one data entity on one endpoint, and if you have relationships, you would use the path names for it. You wouldn't do any embeddings. Caching is something that's also interesting in GraphQL. So let's say you're taking all these REST endpoints, you're mapping them to GraphQL. How are you going to be handling caching? If you do this from maybe a JavaScript applications, you use things like 10-stack query, or maybe use browser cache to make sure you don't do any unnecessary things. If you are sort of mapping all these endpoints together, and we took the Twitter example, where you would get a list of tweets, and then for every tweet you would get an ID of the user that tweeted this, you need to send a second request, or maybe you need to send 500 requests that got all these different users. There probably will be an overlap. I mean, if you search for GraphQL, you're probably going to find multiple tweets from me, so you would have duplicate user IDs. If you don't implement any caching or any smart routings, you would have all these duplicated data fetching requests, which you don't really want to do. So in GraphQL, you're able to cache on multiple ways. You're able to cache in between your results. You're also able to cache an entire query or operation based on the name of the operation, or also how you named the actual operation yourself. Whereas with REST, you typically cache on the endpoint only. Authentication is a whole other thing in GraphQL that I can go on for days. But typically, I'd say it's pretty similar to REST. You pass a JSON token to JSON web token to your GraphQL API, and you can figure out what you like to return and what you don't like to return. You can decide to do it more on a query level, which is more similar to REST API, where you would define which endpoints are available to certain users. And for GraphQL, you're able to do the same on operation level. You could also do it on field level, meaning that you would only return a subset of data in case someone has insufficient rights. And rate limiting is, well, even another subject we could discuss later. So how would you actually implement this? You have multiple options. I guess the easy way to get started is create your own GraphQL server. There's tons of frameworks and libraries out there. As I mentioned in the beginning, GraphQL itself, it's not a framework. It's also not a library. But in the sort of GraphQL GitHub repository, you can find a library called GraphQL.js. And this is sort of a GraphQL implementation for a basic JS server. But there's much more. If you build a GraphQL server, there's all sorts of frameworks and libraries in different programming languages. I typically say it all starts with a schema. You need to define your schema, which contains all the data types, all the operations you have. You need to write these resolvers, and these are really important because in the resolvers you're getting data for these types in your schema, and then sometimes you also have context. And context is more like a overarching piece of code where you would do things like authentication or caching over multiple requests. So in the beginning I showed you this slide. So what you would need to do if you create a GraphQL API based on your REST, you of course need to take into account all these sort of patterns for REST we discussed. And you take these resolvers, and in these resolvers you would do the data fetching to your REST endpoints. Of course you need to implement some smart things there that most GraphQL frameworks are able to help you with. There is a concept called data loader, so this would help in case you're doing duplicate requests, in case you want to prevent getting the same data entity twice. There's a data loader pattern that will help you do this. And as I mentioned, the GraphQL ecosystem is very extensive. So you have libraries for most languages. They're really good ones in .NET, in Go. At my company, we use the Go one as well. Most of them are for JavaScript and TypeScript, Kotlin, Java. They're pretty good frameworks for mostly for most programming languages, so that's a good thing to know. It's also a misconception that GraphQL is only for JavaScript developers. So even though maybe the first set of users of GraphQL were JavaScript developers, GraphQL can be used with all the cool programming languages today. So if you decide to build your own GraphQL server, there's many pros. They give you control over the servers. You're able to do everything you want in exactly the way you want to do it. But maybe you already invested all this time and energy into REST, and you don't want to reinvest the same time and energy. And you also need to take into account any scalability. So I often hear from people that they build a GraphQL API, they have their first set of queries, they maybe mapped some generic endpoints like products or users, and they're seeing a good experience. So they sort of tested their MVP or POC internally, and then they start to do more. They start to add authentication, they start to add all sorts of complicated relationships with other data types. This is probably where GraphQL becomes more difficult, because in theory your schema could be sort of nesting indefinitely. If you have users that are writing posts in maybe a blog, and you have a relationship between the two, so you could retrieve all the posts for a user, but you could also retrieve the user for a post. You can imagine that this could go in loops almost indefinitely. So these are things you like to take away in GraphQL. But you're also giving a lot of sort of autonomy to the user of your GraphQL API, so you need to make sure that scalability is covered there. Because with GraphQL, you only see the tip of the iceberg. You see the schema, you see the playground, or using Postman or some other API discovery tool, but you don't really see everything that's going on underneath. And I once tweeted this, why front-end developers think backend is easy, because there's all these things going on that you don't really see as a front-end developer, which makes the life of a front-end developer pretty easy sometimes. You only have to worry about component libraries and state management, but there's much more going on in the backend world. So both professions have their own challenges. As a front-end developer, you don't really see whatever is going on underneath. So another approach you could take is a schema-first approach. So at my company, we do this as well, but there are plenty of other examples where they do something similar. And they typically use the sort of GraphQL schema as a sort of truth. So you don't really create the resolvers. You would create a schema, and in the schema you would make annotations to the underlying endpoints. It will look a bit like this. You would map your REST API to GraphQL types, and then you would make the annotations to all the underlying data sources directly from your schema. There is even libraries that help you do this directly from a sort of JavaScript application, so you won't even have to create your own backend. You could map a schema to a REST API endpoint. So what we do, for example, is transforming REST into GraphQL sort of automagically. There is also libraries that help you to take an open API spec and transform them into a GraphQL API. So that's pretty cool. I would really advise, if you'd like to go this route, to sort of go into GitHub, search for GraphQL, search for your favorite programming language, and try and find whatever fits your approach. We do it a bit like this, but I don't want to bore you with any of the implementation details. I'll be around for the after party in case you'd like to know more about how we specifically help you to build GraphQL APIs. It looks a bit like this. So we take a GraphQL schema, and we make these annotations to your REST APIs. As I mentioned, there are different libraries and frameworks doing something similar, which is pretty nice, because I truly believe if you're new to GraphQL, you don't want to be bothered with building all these resolvers, all these functions, making sure your data sort of skills. You want to leave it sort of up to the professionals, the people that know how to build GraphQL APIs, as you remember that tip of the iceberg. So the other thing, the last thing, as I have about a minute left, I'd like to tell migrating REST to GraphQL, or adding GraphQL to your REST API endpoints, it can be done incremental. If you're working with microservices, but you maybe also have a monolith REST API, you maybe recognize the strangler pattern. This is where the microservices will slowly take over from the monolith, and at some point the monolith will be strangled to death. although most companies I know migrating to microservices still have their monolith, but that's a different discussion. It'll look a bit like this, and it looks like I forget the final step. So you would incrementally take all your endpoints and turn them into operations, and finally you would have no more REST API. So to summarize, GraphQL is a query language for APIs, so it will help you to retrieve data in a more developer-friendly way. It will help you to retrieve data from, in theory, an unlimited amount of data sources. It offers a single endpoint for multiple resources. So I mentioned if you're just building for a single database with a single app, GraphQL might not be the best approach because it's really good at bringing together all these different data sources. And there's other tools that help you to get just a type system for your data. But the type system is an added benefit. So I'd say it shouldn't be the only reason you choose GraphQL. It should really be an added benefit. I guess that's also where some of the confusion around GraphQL sometimes start. It's more than just the type system. And with that, I like to end, and I like to tell that also GraphQL will help you make your backends more composable long term. So we saw the strangler pattern, and it's a really good approach to bring sort of all these data sources together. So thank you, and I'd like to stay in touch. If you are at the after party, please ask me any hard GraphQL question you might have. Thank you.